Press the bell icon on the YouTube app and never miss another update.
Hello friends, this is the second lecture of इंजीनियरिंग मैकेनिक्स। हम लोग का जो 1000 MCQ सीरीज चल रहा है, ये दूसरा लेक्चर है। ठीक है, क्वेश्चन देखिए। क्वेश्चन नंबर 26। ए satellite is kept on moving on its orbit around the earth due to A. Centrifugal force, B. Centripetal force, C. Gravitational force, D. Resultant force acting on the satellite. B. Centrifugal force. Next question, which is not a fundamental unit? A. Mass, B. Length, C. Time, D. Force. D. Force. Force is not a fundamental unit. Force equal to mass into acceleration. Okay. MLT to the power minus 2. Time है, length है, and mass है. Friends, question number 27. Which of the following theorem is used for the equilibrium of the body applied with three concurrent coplanar force? A. Varignon's theorem, B. Hamilton theorem, C. Lami's theorem, D. Pythagoras theorem. C. Lami's theorem. This is the concurrent force. Concurrent force यानी their line of action at intersect at the same point. Okay, then we can apply the sine rule like f1, f2, and f3. This is the theta, alpha, and the gamma. Then we can write this f1 by opposite angle sine gamma equal to f2 by sine theta. ऐसे ही लिख सकते हैं f3 by sine alpha. Friends, question number 28. Two force 40 Newton and the 30 Newton acts at a right angle to each other on a particle. The resultant force at a right angle, two force act 40 Newton and 30 Newton. This is the 40 Newton, the 30 Newton to each other. The resultant force, this is the R resultant. Okay, so the resultant R equal to x square plus fy square, 40 square and 30 square, horizontal and vertical square. ओके, ऐसे करोगे तो आएगा 1600 प्लस 900 यानी √2500. दिस इज द 50 न्यूटन. Question number 29. Which of the following is a vector quantity? A. Mass, B. Momentum, C. Angle, D. Speed. B. Momentum. Momentum is a vector quantity. Next question, what are the equilibrium conditions to be satisfied for a particle applied with a system of the non-coplanar concurrent force? A. Summation fx equal to 0, summation fy is 0. Summation fx equal to 0, summation fy 0, summation fz 0, mx 0, my 0 and mz 0. Summation fx 0, fy 0 and mzx 0. Summation fx 0, fy 0 and summation fz 0. Option D is right. This is concurrent force. For this concurrent force, non-coplanar fx 0, fy 0 and summation fz 0 equilibrium condition. If there is a non-coplanar non-concurrent force, then B is the answer. Fx 0, fy 0, fz 0 and movement of the x, y and z direction is 0. Friends, question number 31. If the sum of all the force acting on the body is 0, it may be concluded that the body A must be in equilibrium, C cannot be in equilibrium, C may be in equilibrium provided the forces are parallel, D may be in equilibrium provided the forces are concurrent. D may be in equilibrium provided the forces are concurrent. Okay, because there is a chance of coming the movement. Question number 32. A load of 16.5 kg is lifted through a height of 3.4 meters. Find the work done in kg meter. Work done is mgh by g. Gravitational force कट जाएगा, so m into h in the work done is kg meter. So m 16.5 into 3.4 3.4, इससे कैलकुलेट करो करके कितना है देखो. It's coming 56.1. Next question, question number 33. Non-coplanar concurrent force are those whose different plane and concurrent line of action is intersect at a point, meet at one point but their line of action do not lies in the same plane. Do not meet at one point and their line of action do not lies in the same plane. Meet at one point, their line of action lies in the same plane. Yes, C is the right. Mm, Sorry, non-coplanar. A is the right. Meet at one point, so concurrent, but their line of action do not lies in the same plane. This is non-coplanar. The angle between the two forces when the resultant in maximum and the minimum respectively. We are know that resultant force for the parallelogram theory P square plus Q square plus 2PQ cos theta. If theta equal to 0, if theta equal to 0, then it is maximum P plus Q, and minimum when theta equal to 180, then R equal to P minus Q. 180 degree, 0 and 180 degree, 180 degree पे आएगा P minus Q, 0 पुट करोगे तो cos थीटा पे रिजल्टेंट आएगा P plus Q. Question number 37. If a number of forces act simultaneously on a particle, it is possible to replace them by a couple. Only single force cannot replace them. C. To replace them by a single force through center of the gravity. D. To replace them by a single force. It is possible to replace them by a single force. Next question, Lamar's theorem states that if the three coplanar concurrent forces acting on a body keep it in the equilibrium, then A. Each force is proportional to the cosine of the angle between the other two forces. B. Each force is proportional to cotangent of the angle between the other two forces. C. Each force is proportional to the tangent of the angle between the other two forces. Each force is proportional to sine of the angle between the other two forces. D. Each force is proportional to the sine of angle between the other. Identify the correct statement of the principle of the force transmissibility from the following. A. If two forces acting simultaneously on a particle be represented in magnitude and direction by the two sides of a triangle, taken in order, their resultant may be represented in magnitude and the direction by the third side of the triangle taken in opposite order. B. The algebraic sum of the resolved parts of a number of force in a given direction is equal to the resolved part of their resultant in the same direction. See, if a force acts at any point on a rigid body, it may also be considered to act at any other point on its line of action provided this point is rigidly connected with the body. D. If a number of forces are simultaneously acting on a particle, then the resultant of these forces will have the same effect as the produced by all the forces. C. The force acts any point on a rigid body. It may also be considered to act at other point on its line of action provided this point is rigidly connected with body. The total weight of a body is an example of A. Traction force, B. Volume force, C. Point force, D. Distributed area force. B. Volume force. Friends, question number 42. A number of the forces are acting simultaneously on a particle. The resultant of this factor will have the same effect as produced by all the force. The principle is known as resolution of the forces, physical independence of the forces, transmissibility of the forces, D. Equilibrium of the forces, C. Transmissibility of forces. Sorry, B. Physical independence of the forces. Question number 43. Two forces of equal magnitude F acts on a particle and the angle between these forces is theta. The resultant of these forces is given by 2F cos theta by 2 as the resultant R होगा यानी okay, so resultant R equal to root over f square plus f square plus 2f स्क्वायर cos थीटा इधर से f कॉमन आ जाएगा एंड 2 इधर कॉमन आ जाएगा सो 2 रूट 2 f स्क्वायर यानी 1 प्लस cos थीटा रूट 2 f स्क्वायर प्लस 2f स्क्वायर कॉमन जाएगा तो 1 प्लस 2 cos थीटा 1 प्लस cos थीटा यानी रूट 2 f स्क्वायर into 2 cos थीटा बाई 2 cos थीटा बाई 2 सो इधर से आएगा 4 4 यानी 2 f स्क्वायर दोनों है f cos स्क्वायर थीटा यानी cos थीटा बाई 2 ऑप्शन बी इज द राइट Question number 45 statement if the three coplanar forces acting at a point are in the equilibrium, each force is the proportional to sine of the angle between other two is known as a triangle law of forces, B. Lami's theorem, D. Laws of parallelogram of the force, D. Albert principle, B. Lami's theorem. Friends, question number 46. The forces for which the lines of action lies on the same plane but they do not meet one point. Same plane यानी coplanar, not one point तो non-concurrent. Coplanar and non-concurrent force. Option A is the right. Question number 47. Two forces are acting at a point with a magnitude and direction represented by the two adjacent sides of a parallelogram. Their resultant represented by the diagonal of the parallelogram passing through that point. This is based on which law? Laws of triangle of the forces, laws of parallelogram of inertia, laws of parallelogram of force, laws of triangle of the inertia. C. Laws of parallelogram of force. Parallel for parallel Parallel forces have their line of action tangential to each other, transverse to each other, parallel to each other, perpendicular to each other. C. Parallel to each other. So this is the parallel line of action of the force.